Hi, everybody. My name's Sam Clegg. This is Ben Smith. We're engineers on the native client team at Google, and we're here today with Kester and Brian to talk about some of the things we've been working on recently to make it easier to bring native code to the web. We're going to split the talk into three parts. First, Ben and I will talk about some of the work we've been doing on the SDK, and then Brian and Kester will each talk about how they've been using native client in their work in other parts of Google. So we'll start with a quick introduction. For those who don't know, Native Client is an open source project developed at Google with the goal of being able to compile and run native code in the browser securely. So this technology has been available to Chrome apps in the Web Store for a long time now. You just saw the presentation about how the Web Store works. And the portable native client, or PNaCl as we call it, is a newer technology that builds on native client and adds an architecture and OS-neutral binary format that allows native code to be run in the open web on any web page. So as a developer, if you have a native app written in C or C++, what do you normally need to do to bring this to the web using native client? Traditionally, you would have to use what we call the Pepper APIs, which are the APIs available to native client modules for communicating with the outside world. So you'd normally need to identify all the parts of your application that do I/O, such as graphics, sound, and file I/O, and either replace or modify those parts of your code. Also, Pepper is a traditionally asynchronous API, so you might need to modify the way your application runs and handles events. So this is a fairly significant burden for an application developer to have to modify their code in this way. And also, one of the main benefits of having access to C and C++ is being able to use the myriad of existing libraries that are out there in the world, in the open source world. And so we wanted to make it as easy as possible to bring those libraries to native client without any modifications. And that's what we've been working on. And to that end, we've built a library called PNaCl. And this is essentially a POSIX emulation layer for native client. And it allows you to take your applications that are written for POSIX-like platforms, such as Linux and Mac and Android, and bring them to the web with far fewer changes and far less effort. So PNaCl implements many of the POSIX APIs that you'll be familiar with, such as standard I/O and the BSD socket API. It also adds the ability to make blocking calls and use a traditional C-style main entry point for your application. One interesting part of this is that because we're running in the web platform, we don't have direct access to the host's file system. So what PNaCl does is build a virtual file system out of file-like objects that are accessible on the web platform. So for example, files on your web server or files in Chrome's local HTML5 storage become available through the normal Unix file model that you're familiar with. You can open, close, read, and write all these things as if they were files. And you can even write your own file system types so that your application feels like it's running in a POSIX environment and requires less porting. So one of the things that PNaCl has facilitated is the growth of the NaClPorts project, which is a repository online of existing applications and libraries that have already been ported to native client and run in Chrome. And we have over 100 libraries and applications there today. Things like language interpreters like Python, Ruby, and Lua that all run in Chrome, and middleware like FFmpeg or SDL that you can take advantage of today if your application needs that. And a lot of these ports have been facilitated by PNaCl, and many of them have zero modification from the upstream, thanks to this POSIX layer. So now I'm going to hand over to Ben, and we're going to show you some of the applications that are running live in Chrome today.
Thanks, Sam. So the first one is going to be well known to probably 50% of you. It is the famous text editor Vim. And Sam will be loading it here. You can see it. This is pretty much unmodified. You can see him now adding some syntax errors to some, no, almost adding. So it looks very much like it's running in a terminal, but this is actually a Chrome app. And one of the benefits of that is that it will run on Mac, Linux, Windows, and... Oh, did you lose it? and Chromebooks. There we are. I thought you said you were a Vim whiz. Okay. So that's the text editor Vim. Moving on to something that's a little bit more visual. This is the Cocos 2DX game engine. Cocos 2D, according to the Cocos 2D authors, is the most popular mobile game 2D engine. And so this is just some examples of some 3D graphics that can be rendered using this engine. So very simple to take a game that was written originally for mobile and bring it to the web, and also Chromebooks. All right, the last one is another 2D game engine. This is called Love. This game in particular is a game that is a mashup between Super Mario Brothers and Portal. Used to be that you could only play it on the desktop, but since we ported it to PNaCl, you can play it directly in the browser. So you can see Sam here trying to create a portal. All right, keep going. And there he goes. Very nice. So these are just some of the cool things that you can do now with very, very little porting at all. And I'm going to hand it off to Kester, who's going to talk about some cool stuff he's going to do next.
Thanks, Ben. So I'm going to be talking about the work we've been doing porting IPython to PNaCl. And this work's involved Google. It's also involved external open source contributors such as Matthew Turk from the Center for Supercomputing Applications. And we've also started working with the IPython dev team. So for those of you who haven't heard of IPython, IPython Notebook is an environment that allows users to mix text, code, and the output of code in a single notebook. And it's very popular for things such as data analysis, because people can do some code, they can see the output of that, for example, in the form of a graph. Then they can do some more coding and see some more output. And then after they've done with this workflow, they have a written record of every step that they've taken. So it's very reproducible. And then they can add text annotations, as you see here. And they can share this with other people and publish it. So our goal was to integrate IPython better with web technologies. We've done two things. The first is that we ported IPython to PNaCl. And this allows for a single one-click install from the Chrome Web Store. So currently, IPython is a desktop app, and it has a somewhat complicated installation process, which is make it hard for some users to use it. And but when we've ported IPython to PNaCl, we're able to now package it as a Chrome Web Store app, which means a person can download it from the Chrome Web Store in a single click, and it's going to work the same on every single platform. The other thing we've done is integrated the user interface with Google Drive. So previously, IPython was using the local file system to manage notebook files. And this could make collaboration difficult because, for example, people might have to email files backwards and forwards if they wanted to collaborate. But we've made that much easier by integrating the front end with Google Drive so that all the notebook files live on Google Drive. And furthermore, we've integrated with the real-time API so that people can multiple people can work on the document at the same time. So as you can see here, it's very much like a Google Docs style interface where you have individuals, you can see who's in the document at any time, you can see where they are in the document, and you can have multiple people working on the same document at the same time. So how do we do this? This shows the architecture of the Chrome app. So Chrome apps contain a front end, which is written in JavaScript and HTML. But they can also contain PNaCl files, PNaCl binary files. And in this case, the PNaCl binary file is running the Python runtime. That is the IPython kernel, which is executing the Python code. So all of the execution is done inside the browser. A typical workflow for a user would be to start off in the Google Drive website. They can open a file by clicking on a file, or they can create a new one. That will launch a window in the Chrome app. And then the front end will talk to the Google API servers to implement the real-time collaboration. As a developer, if you're going to implement such an app yourself, Chrome apps are basically packages that contain not only the front end, which is like a web page living in a window, which contains JavaScript and HTML, but then when you want to package it with PNaCl, you also can include the PNaCl binary inside the app, along with a manifest which contains permissions. In our case, one reason we prefer the Chrome app is because then we can have full access to the web without cause restrictions. I'm now going to demo this app. So I start in the Google Drive website. I'm going to click New and create a new document. Doesn't look very healthy there. I'm going to try one more time. OK, that's even worse. So I'm going to start from one that I already have running. Also seems to have hung. So I'm just going to do a reset of this. Let's try this again. OK, that's looking better. So it's creating a new notebook in Google Drive. And once it's created this notebook, we'll be ready to execute some code. So if I type in some code such as print hello, it will execute this code, and the execution is happening in the browser. I'm just going to show a very quick demo, which I won't be able to narrate, but I'll just type it in very quick. Oh, thanks. Thanks a lot, Sam. So what I'm doing here is I've imported a library called NumPy, which is a numerics library. And I'm just going to show some autocomplete here. So I can find the random normal distribution. And then I'm going to generate 10,000 of these and add them up to get a random walk. And then if I plot this, then as you can see, that's the plot. So this is just a very simple, thanks Sam, that's a very simple example of the sorts of things you can do with this notebook. A very typical example of something someone might do in real life is downloading some data off the internet, doing some analysis, and then with our software, they can then share this with other people, publish it, and so forth. I'm now going to hand off to Brian, who's going to talk about his team's work with PNaCl.
Thank you, Kester. So I work on the Google Earth team, and I want to talk to you a little bit about something related to this, which is working with existing JavaScript APIs in native client. So the subtitle of my talk is Why It Doesn't Have to Hurt, and I'll get to that in a minute. So in the battle days that many of you may remember, the world was dominated by the Netscape plugin API, NP API. And here's an example of some NP API code. We have this magical embed tag in the document, which just sort of grows some JavaScript properties and methods which you can call. There's a lot of magic involved with this process. There are a lot of reasons not to like NP API. It was a great technology at the time, but the time in question was like 1995. So it's really hard to work with, hard to write, hard to debug. It has security holes the size of small countries. And most relevantly for all of us, it is deprecated. It is going away in Chrome. It is probably going away soon in Firefox. Internet Explorer never supported it terribly well. We don't want to use NP API anymore. Obviously, we would like to consider native client to be the replacement for NP API, but if you write native client code to do the same thing that we did in the previous slide, you'll see that it looks very, very different. There's now JSON messages being passed back and forth, and it's not immediately obvious, but if you look closely at this, you'll see that it is asynchronous code. There's an event handler that is processing the replies for all these messages. So if you have an existing synchronous JavaScript API that you want to port away from NP API to native client, you can't at all. But that is about to change, and I'm going to demonstrate how. We have just this week added to a dev channel of Chrome near you a synchronous version of the APIs for posting and receiving messages. So this is the new code. And you'll see it looks very much like the old code, except that now there is an and-await response on the end of that message, and it has a return value. So this is actually going to do this synchronously and give you back the value immediately. It may not seem like much of a difference. After all, you've still got all these JSON objects floating around. It's still very message-based, feels sort of like an RPC call. But with a small JavaScript shim, which you can write on top of this, you can get this code, which ought to look pretty familiar because it is basically line for line identical to the NPAPI code we wrote in the very first slide. So here's the broad statement I'm going to make. It is now possible, as of this week, to implement almost any existing JavaScript API on top of native client. So to prove this to you, I am going to, by way of demonstration, show you. Actually, it looks like I'm going to have to relaunch it because we restarted everything. So let me do this. This is some of the technology, thank you, behind Google Earth running in a browser in native client. And as you can see, it is very smooth. I'm getting about 60 frames per second here. We have full support for many of the features that you have grown to know and love in Google Earth, such as 3D buildings. So if I zoom in to San Francisco here, and if the Wi-Fi network in the Moscone Center is willing to cooperate with me, you will see here we have full 3D. We also have some JavaScript and HTML running on top of this view. So all of this rendering is happening natively using native client. But for example, I can do a search for, pizza near the Moscone Center. And these results, again, assuming that the Wi-Fi here is going to cooperate with us, are rendered in pure HTML, and they can interact. So I can zoom in to these various results and see them on the map. I can even click through and see information about each of these. These are, again, rendered in pure HTML and JavaScript. We can interact in more sort of fundamental ways by turning layers on and off. So here we're going to see, in a minute, traffic information. At least that's the idea. I guess traffic is at a standstill. Well, that happens sometimes. Let's try transit routes instead. I think that should be... Well, you may have to take my word for it, but it does work. And we even have some features that don't exist in Google Earth today. For example, you can switch back and forth from the globe to a flat map with all of the same information plotted on it. And again, the network is loading fairly slowly. So, and all of this is done with no special code. There is no... There's a small portability layer that Google Earth has had for a very long time, which we've adapted to use the Pepper API. And we have JavaScript code, which is written for this demo. And that's it. Everything else is exactly the code that we deploy everywhere else. And Google Earth is not a simple application. So let's go back here. So there are a few caveats about this. One is that with great power comes great responsibility. When you have a blocking API like this, you are actually going to block Chrome's renderer thread. So don't wait long before returning, or your users will notice the performance drop. And also, similarly, for the same reasons, prefer the asynchronous API whenever you can use it. The reason why that is the primary API is for performance reasons, but now if you're porting an NPAPI API or some other API that requires synchronous calls, you have that option open to you. So happy hacking, and if you're wondering what to do next, we have some suggestions for you. First of all, contribute your open source product, or for that matter, somebody else's open source product to NaCl ports. The URL is right here. And if you want to learn more about NaCl and PNaCl, go to gonacl.com. Thank you very, very much. So I'm going to open it up for questions if anybody would like to.
So you guys said that you ported the IPython notebook to PNaCl. Two questions. First of all, is that somewhere to be found on the internet for me to use?
Yeah, it's actually inside the NACL ports repository.
Oh, okay, very good. And secondly, you said it's ported to PNaCl. Does the porting process differ when porting to NACL when compared to PNaCl, or is it basically convertible?
It's slightly different. There's a different compiler. With PNaCl, we're using a Clang-based compiler, LLVM, and with NACL, it's a GCC-based compiler. The other main limitation is that PNaCl doesn't support inline assembler. So if you have inline assembler for x86 or ARM, today you can't use that in the PNaCl world. But it does support intrinsics for SIMD primitives, so you can get some of the high performance that you might be looking for in your assembly code.
Thank you.
I just wanted to add that only the kernel is on the is on NACL ports right now.
But you are planning on publishing that app publicly in the future, right?
We'll be making an announcement next week at the SciPy conference regarding the open sourcing of the rest of it.
Cool.
You're competing with Inscripton and ASM.js, so can you just talk about the trade-offs between the two and where you think each one is stronger?
Yeah, there's a lot of similarities there. Some of the things that we allow are currently impossible in Inscripton, like background threads and blocking APIs. So we can actually implement like fopen and fread where it goes to the network and blocks for any amount of time. So some of the stuff you have to do to go to Inscripton, you don't have to do to go to NACL today. There are lots of different trade-offs. Our stuff has been available for a bit longer, so it's a little bit more mature, probably. Like it's been in production for several years now. There are probably other people here who can speak more to the subtleties between the two. But the PNaCl and Emscripton both use the same LLVM-based toolchain, and they even share some of the LLVM passes. So there's some amount of convergence that the two teams are, and they do communicate, the two teams. So you can expect more convergence in the future, I think.
Is there an example? Obviously, probably don't have the source code for Google Earth out there, but do you have other example code that uses, does that use OpenGL?
Yeah, so that uses OpenGL ES2, which is what native client provides. So you can either look in the SDK for our examples, or you can look on NACL ports, the project I mentioned, where you can see over 100 open source applications that run inside native client.
And you were also talking about being able to have JavaScript on top of
Yeah,
PNaCl. What exactly do you mean, and how does that work?
So in native client, you can either render to a 2D canvas or a 3D canvas like WebGL. And the canvases, if I'm right, behave very, very similarly to HTML5 canvas and 3D canvas. And so it's just an element.
So it's just a surface that you can. It's a surface in the JavaScript-based web page.
So it's actually even simpler than that. You can simply overlay divs on top of the NACL embed, and it'll composite correctly with alpha and everything.
Okay.
So.
Okay. Good. And this is only available in Chrome still?
Yeah, it's only available on Chrome.
You haven't convinced anybody else that it's an open source project. Presumably, it could be included.
Sorry, say again?
I said NACL, PNaCl, open source project. Conceivably, could be included in Firefox or whatever.
Conceivably, it could be, but I don't believe that there's any plans for other browsers.
Does this run on Chrome on Android?
It does not, no. Not currently, although there are plans.
Another thing to point out is the Pepper.js library, which lets you take an application that's targeting portable native client and the Pepper APIs, and then compile that using Inscripton, and we'll create polyfills of the Pepper APIs that target JavaScript backends. And so, given that you're using the Pepper APIs, it will make your life easier to then port to an ASM.js version. So we're definitely trying to work with the community here and the different technologies available to give our developers the best option.
Yeah, so using that technology, you can produce a JavaScript file using Emscripton and a PNaCl file using our toolchain from the same source code. That's the idea. So then you can have a cross-platform solution.
And there are examples of that on pepper.js. I think it's trypepper.js.org.
More question?
So if I want to use SIMD, then the x86 and ARM intrinsics are different. So what do you actually support?
So it uses LLVM intrinsics, which are recently introduced, and there are examples of that in the most recent SDK as well. So it will look very much like anything that's not actually implemented by that processor will be sort of filled in whatever way necessary. So it will always work. It's just a question of will it be? It won't necessarily be as fast if the ISA doesn't support it.
Well, I'm not familiar with the LLVM intrinsics. Are they like 4 at a time, or 8, or 16, or what?
You can actually specify. There's many different sizes. I think currently we only support 128 bit wide, but we have plans to support larger, is my understanding.
Okay, thanks.
And if you want to learn more about Portable Native Client and SIMD intrinsics, there's also 2 videos that we recorded and launched under the Google I/O Dev Bytes site. And so you can go watch JF, who implemented the SIMD intrinsics, tell you about exactly how he did it and how he chose which subset was super portable. And then also Brad Nelson, who's talking about a new developer editor that we have created so that you could actually debug and edit your programs running on a Chromebook. So go check that out.
Yeah, this development environment actually uses PNaCl to run GCC and Vim and Bash and Make all inside of a tab. So we're trying to get as much of POSIX as possible to allow you to actually do your development in Chrome on a Chromebook.
What about Emacs?
Emacs is coming. We have that in the pipeline. The build system for Emacs is a little bit crazy, so that's the main problem there.
You can do micro.
Yeah, yeah.
Any other questions? Cool. Thank you so much for listening, and go check out PNaCl.